We're continuing our unit here on exponents, and so we're going to talk today about how to multiply and divide powers. So we're really going to start to get into our objective here, which is that I can understand and apply the laws of integer exponents to simplify expressions. We're going to get into these laws of integer exponents today. So specifically, the first law that we're going to look at here is called the product of powers, and it says to multiply powers with the same base, add their exponents. And so it gives us a couple of examples here of what that looks like. So in other words, if you have 2 to the 4th times 2 to the 3rd, see they have the same base, all you do is add those exponents together. And it shows you here what that would look like for any number. Say you have the same base, whatever that might be. If you have two different exponents, you could just, or if they're the same, you can add those exponents together. So you might think that because the exponents tell us how many times the number is being multiplied times itself, that we'd multiply those, but we don't in this case. We're already showing multiplication with the exponents. So what I'd like you to do is I'd like you to rewrite this problem with me here. That's 2 to the 4th times 2 to the 3rd, because I want to show you what this literally means and why we add those exponents. So remember, 2 to the 4th means 2 times itself 4 times. So I want you to rewrite that as 2 times 2 times 2 times 2 times 2 to the 3rd. So 2 to the 3rd is 2 times 2 times 2. So you can see how many times 2 is being multiplied times itself altogether. 2 times 2 times 2 times 2 times 2 times 2 times 2. 2 times itself a total of 7 times 2 to the 7th. So you can think of this as like 2 times itself 4 times 2 times itself 3 times. Altogether, 2 is being multiplied times itself 7 times. So that's why we're able to just add those exponents together. Now that only works, again, when they have the same base. Okay? So let's take a look at the next key concept here, which is called the quotient of powers. Quotient is the answer, of course, as you know, to a division problem. So this is about dividing. To divide powers with the same base, we're going to subtract the exponents. So let's take a look at this. We have 3 to the 7th divided by 3 to the 3rd. All you got to do is keep the base the same, and you subtract those exponents. So I want you to go ahead and write out with me again this problem. This is 3 to the 7th over 3 to the 3rd. Yeah, 3 to the 3rd. So we're going to write this as 3 times itself 7 times up here. I'll show you why this works. That's right, 1, 2, 3, 4, 5, 6, 7, okay, over 3 to the 3rd. 1, 2, 3. Okay, you probably know by now that any number divided by itself is 1. So we have here what we can do what's called canceling out here, because we have a bunch of things that equal 1. We have 3 over 3, which equals 1, 3 over 3, which equals 1, and 3 over 3, which also equals 1. And anything times 1 is itself anyway. So we don't need all these 1s anymore. Anytime you have the exact same thing on top as you on bottom, you can cancel that out. So we can cancel out again and cancel out one more time. And then we don't have another 3 down here to cancel this out. So these all 3 stay up top. So we have 1, 2, 3, 4. We have 4 of them. So 3 to the 4th. So that shows us why this rule works here of being able to just to subtract those exponents instead of dividing them or dividing the powers. It shows us here that we're what these actually equal, and we just cancel those out until we see what's left. So we might reference this as why this works again, but the rule is just to subtract the exponents when you're dividing powers. So let's do a little bit of practice with this. Flip over to the back side of your notes there. And we'll do some multiplying and some dividing, and we'll see what this looks like kind of in some different situations. So number 1 is 4 to the 5th times 4 to the 3rd. So the rule is, if the base is the same, keep the base the same in the answer. 4 times itself 5 times, 4 times itself 3 times, altogether 4 times itself. You add the exponents, 4 times itself 8 times. Okay, we're just simplifying this. We're not coming up with the final answer. It says express using exponents. So we're not going to evaluate these. We're just writing these with exponents in a simpler way. Number 2, we're going to get to things a little trickier here. Negative 2a, and then in parentheses next to that, negative 3a to the 4th. Okay, so you have some things that have a base and an exponent. Really, there's just one of them here that has a base and exponent. You're looking for things that have a common base. And if they don't have a common base, like -2 and -3, and they're just regular numbers, you're just going to multiply them like you normally would. So let's go ahead and write out, I want you to write this out with me here, what this would be if we didn't write this with exponents. It'd be -2a times -3, and then a times itself 4 times. So a times a times a times a. So this is literally what we would have without the exponents. So the two regular numbers here, it's just multiplication. They're not powers, they don't have exponents or anything, so we just multiply them like normal. -2 times -3 is +6. And then we have a being multiplied times a times a times a times a. So altogether we have 5 a's being multiplied altogether, so a to the 5th power. Okay, so if they're just regular numbers, we just multiply or divide like normal. So let's see what that looks like here on number 3. We have 4r to the 7th times -r to the 3rd. All right, on this one, 4 is not a power, does not have an exponent, and we would multiply that times the regular number over here, but there's no number written. Many of you know by now that if there's no number with a variable, like we see here, like if I just had x, if we have to write something, if we have to pull some number out of there, there's an understood 1 there, okay? So what this really is +4 times -1r. So 4 times -1. Because really what we're doing is we're taking a positive something times a negative something here. So our answer has to be negative. So it's -4. And then we do have a couple powers here. We have r to the 7th and r to the 3rd. So we multiply those powers. Base stays the same, and we add those exponents together. 7 plus 3 is 10. So it ends up being -4 r to the 10th. All right, let's take a look at number 4. And I want you to write this one down with me. It's 3a squared b to the 3rd times 4a to the 7th b to the 3rd. Okay, once again, 3 and 4 are just regular numbers. They don't have any exponents with them, so we multiply them like normal numbers. 3 times 4 is 12. That's the first part of our answer. Then we do have some power, so we look for things that share the same base. A to the 2nd, a to the 7th, keep the base the same, and add those exponents together. 2 plus 7 is 9. Okay, and then we have b that has a same base, b to the 3rd, b to the 3rd, keep the base the same, and add those, b to the 6th. So that is that multiplication problem in its simplest form. 12, a to the 9th, b to the 6th. We can't combine anything else together there. All right, number 5, let's do a little dividing here. Y to the 6th divided by y. We divide powers. You keep the base the same. This is y to the 6th divided by y, so it still stays y to some power. And you can think about this for a minute, and I want you to write this with me. Let's think about, we're going to subtract these exponents, right? So 6 minus, now there's no exponent written, but this still counts as 1. This still counts as a y. So now another thing you need to remember about variables is if there's no exponent written, then there's an understood exponent of 1. So really this is 6 minus 1, not 6 minus nothing. We'll talk about exponents of 0 later, but 6 minus 1 would still give you 5. Write this out with me here. This would be y times itself 6 times up top over y times itself once. So this goes back to that example that we did on the other side there. The 2 y's cancel out, and we're left with 1, 2, 3, 4, 5 y's. If you need to do this for a little while with the division or even multiplication, where you spread this out to show what this really looks like without exponents, to see how this works, you can do that if you want to. It's better to be able to just remember the rule, and sometimes you have to go back to why the rule works there. So that's going to end up being y to the 5th. All right, number 6, last one here, is 12c to the 7th over 3c squared. Okay, same with multiplication. If you just have regular numbers, and 12 and 3 are just regular numbers, they're not powers because they don't have exponents, you're just going to divide them like normal numbers. 12 divided by 3 is 4, but then we do have a couple of powers here. You divide powers, keep the base the same, and subtract those exponents. 7 minus 2 leaves you with 5. So this is 4c to the 5th. When we get back to class, we'll do some more of these where you do some on your own, and we'll check those in class. But you've got an introduction now to multiplying and dividing powers.